There's a lot of different oscillators out there in Eurorack land, and Lord knows I am the first to spend money on oscillators. They are fun and exciting, and like getting any new module, it feels like you've got a new case again. I think that's the best quote, really. Getting a new module transforms all of the things that you have. But I keep pounding the drum for being creative with modules that you already own. And to that end, there's some interesting things that you can do to generate sound from modules that you wouldn't particularly think necessarily as audio sources. Of course, this whole thing is modular, so we can patch and create functionality with creative patching. So let's do a little bit of oscillator creation. One of the most classic examples is a LFO, which traditionally would be sub-audio level, low-frequency oscillator, made fast enough to become an oscillator. That's a little bit of a cheat, really, because it is just an oscillator. But as a good example of this, here is the make noise maths, which is a great many things. And one aspect of it is that it's an LFO. So if we push this little button, then this starts to cycle. And we have controls to set the rising of the signal and the falling of it. So it's basically like a triangle wave LFO in this instance, but we can make it go very fast. So if I plug the output into our speakers, you can kind of hear, that's probably messing your speakers up, but that's very low frequency. We're just plugging the output of this directly into the mixer, which is going out to our speakers. So, but of course, if we turn up the volume, we start to hear sound, but we can kind of shape the sound because we get controls over the rises and falls. We can make it into a triangle or a rising and falling saw, and it's pretty crude because in adjusting the falling and rising, it's not just a tone control, it's also adjusting the pitch of the oscillator in this case. What's cool though is that we can use a sequencer. Let me find a patch cable so we can use the output of the sequencer, everyone running here to the side. And if I put that into the both control, it changes the rate of both the rising and falling at the same time. Which is pretty cool. Very important point with this is it doesn't track 1 volt per octave. It's not accurate, but it's a good example of the classic thing of turning an LFO, which doesn't necessarily track accurately, but we can put it to use as a serviceable oscillator. Cool. However, there is a very interesting thing that we can do with this, and this leads us on to point number 2, which is using a sequencer, an analog step sequencer, as a oscillator. So this is the make noise pressure points and brains. These are actually 2 separate modules, although they're connected around the back. And the pressure points is a touch sensitive sequencer and kind of keyboard. It's based on the Surge TKB touch keyboard, and we can output 3 voltages here. Whenever we push one of these little plates, the stage kind of jumps. And what emerges at that point from these three sockets on the side is basically 3 voltages, which I determine with the associated knobs. So here we are now hearing these, here we are now hearing these, here we are now hearing these, again coming out of here. All well and groovy. The thing is, if you connect brains to the side of pressure points, it turns it into a more traditional step sequencer. Without brains, we would just literally be pushing this, and it's extremely cool. It allows us to get 3 tuned voltages. We could use this to create chords. We could have 4 different chords tuning different oscillators, be they trad oscillators or ones that we've basically hacked out of LFOs. But what's cool is, again, this idea that we can clock this module. So if I use our LFO as a clock source, and I've got an end of cycle output here from the maths, suddenly we start to advance the stages automatically. You can see it sort of carry on by itself. And if I adjust the rate of the LFO, the sequence gets faster and slower, faster and slower. But what is cool here is because this is an analog sequencer, this isn't a digital sequencer, in which in some of those, some of the digital sequencers in Euro and elsewhere, there is a limit to the rate that you can clock it at. This thing can be clocked at audio rates. So if I go faster and then faster and then faster and then faster till all of the LEDs become a blur, what's going to happen is if I put a signal into the output, let me do that. So there's the output. Now this is a control voltage. This isn't traditionally an audio signal. It's too low for us to hear. We wouldn't normally connect it directly to our speakers because not a great deal would happen, but let's do that. So here is the output of the speakers, and you can kind of hear it clicking possibly. I hope I'm not hurting your speakers. Turn the volume down a little bit, but if I start to turn this up, you start to hear a tone. And what's happening is that we're clocking this so fast that we're creating an audio, clocking at audio rates, we're making an audio tone. And we are literally hearing the output of the sequencer. And what's cool is because it's banging through these different voltages at such a high rate, I can adjust them and play around and use what were traditionally the ways of selecting a note as a tone controller. And it makes a pretty boss square wave. And if we do what we did before, which was to take the output of the sequencer, here she is, and stick it into the both input of the LFO that I have clocking this module, then I'm clocking the LFO, I'm changing the rate of the LFO, or the audio rate LFO, and I'm using it to clock this at different speeds. So I'm sequencing the sequencer. Ace. And because it's on make noise pressure points, it has these extra outputs, and nothing at all stops us from tapping those simultaneously and getting a kind of multi-timbral aggressive triple kind of square wave. And we can kind of touch the plate and chop it. So pretty lo-fi, but an interesting thing to do. That will go into a filter quite nicely. Obviously, it's pretty raw by itself. So the other classic trick, which you can do on loads of fixed architecture synths as well, nothing unique to modular, is to self-resonate a filter so it makes a sine wave. So if I take the IntelliGel Chorgasmatron, which I stick that into the input or output even, nothing happens until I turn up the Q, and we'll start to hear a tone. Oh no, there it is. So this is a sine wave, and filters are incredibly good at making incredibly precise sine waves. Funnily enough, they're in many instances a lot better and more accurate at doing it than a lot of oscillators, which derive a sine wave via a different method. And what's cool about the Chorgasmatron is it's a very accurate module. So most notably, as in it has a 1 volt per octave input, which means that we can take our filter again. We have a drive control here, so we can kind of square it. So we get a little bit of tone control. We can make it more square than it is. Slightly changes the pitch as we do that, but it's not bad, seeing as so this is traditionally just a filter, but it's a filter that can be an incredibly accurate sine wave oscillator. So it really is an oscillator and a filter at the same time. Though it doesn't say that on the front panel. So this is awesome. However, Another incredibly cool thing is that we have two of these. So we have two filter blocks, and we can have low pass and high pass and notch as well. And we can do the awesome NS20 thing of kind of having two filters kind of chewing each other apart, which sounds great. But we can, if we do this, the 1 volt per octave input here is automatically copied over to the other side. So if I take the mixed output of the module, which is here, we get a really pretty dual kind of sine wave sound. And this is totally accurate. It tracks as accurately as most oscillators do. But tonally, there are some really interesting things that we can do here. Most notably, ooh, quite like that. That's nice. Most notably, we can frequency modulate one side with the other. So what I can do is if I take the output B, so that we're just hearing this side, and I take the output of A, and I run it into the FM controls here for B, and then do this. Let me get a better control if you use this side. Now we're using the output of one filter to frequency modulate the speed, the cutoff control, which is effectively the rate. Unlike on the old DX7, sine waves are just very good for FM synthesis. I mean, this isn't through zero FM synthesis. It's not accurate like that, but it's a really interesting way of generating new tones. So if you have two filters, you don't need like a complex oscillator to get kind of odd complex sounds and to mess with FM. You can do it with filters. And again, we can tap the, you can use this 1 volt per octave input. And what's cool is because it does that thing of copying one side to the other, it maintains the kind of tuning relationship between the two, which is, in this instance, having a kind of tonal relationship. And again, it's not really designed for sort of, this isn't an utterly accurate thing, but you can get really interesting tones. Very cool. So the last thing that we want to look at is this thing, which is the A1881 BBD module from Doepfer. And a BBD is an analog delay. It's an analog delay chip. And BBDs, you'll see sometimes manufacturers will mention the kind of stages, which roughly equates to the length of the delay time. And Doepfer have a bunch of different versions of the A1881, and the different versions are basically the same module, but shipping with a different chip inside, which affects the stages and affects the maximum delay time. The thing is, we might be tempted to get the longest one, because if we're going for analog delays, we want nice, long, sexy analog delays. That's just kind of, you know, generally having a really long delay on a delay, be it a module or a pedal, is kind of a good thing. It's generally perceived that way, I think it'd be fair to say. But in this instance, it's actually quite advantageous to have a short time. And this is for doing a thing called Kaplan-Strong synthesis, which is using a delay line and a noise generator to kind of excite the feedback path. So let me set up a patch using the A1881 that I have for Kaplan-Strong, and let's see if we can make a delay into an oscillator. Okay, so here's one we just made earlier. So this is a very kind of standard and traditional take on Car plus Strong. And in this instance, what I have done is we are using a noise generator, a white noise source, which in this case is the Truly Crackers module called the RF Nomad. It's actually a shortwave radio for modular synths, as you do. This is the antenna, and I'm just using it as a noise generator. Obviously, it can produce all kinds of sort of white noise. And what I've done is I'm running the white noise through a VCA so that I can control its volume. And that volume is being controlled by the maths. But in this instance, I've got the maths just as a envelope generator. I'm using pressure points kind of more traditionally, just as a touchable sequencer. So every time I touch one of these plates, from this touch gate output from brains, it's generating a gate. And that gate is going to maths. And you can see that it makes math fire, and I can choose the length. Very cool. And again, that is what is controlling the VCA. So whenever I push that, the VCA lets a little burst of RF Nomad through. Cool. Now, this is where the BBD comes in. So what I'm doing, I'm taking that little burst of white noise, I'm sticking it into the audio input, which is here. And the BBD is a delay unit. So literally like, you know, your classic delay, at very high settings, it makes the kind of delay kind of sound. But because this is a slightly shorter delay time, interesting things happen if we create a little feedback loop, if we allow it to feed back on itself internally. So if I mix in the BBD, we were just hearing the dry signal, and then introduce feedback, there was a point where the white noise excites the BBD into feedback, and I'm using the control voltage lane here to change the delay speed. Without it, it'll always be the same speed unless I change that. You see? But in using the voltage here, I can predetermine, based on the setting here, a kind of master tune. And it's interesting, this, you hear how it kind of sounds, you've got the little burst of audio, and I can turn the level down. And I can change the length. It's interesting, the sound, because it's got this kind of almost like scraped sound. And I've got another little lane here, maybe I like. Sort of have to get it. Less feedback. It's fun. And it's really interesting, actually. I mean, this is like, this is kind of more interesting than your trad saw wave run-of-the-mill oscillator. And totally musical. I mean, there's loads of things you could do with this. It's nice being able to set up 4 voltages here so you can kind of have 4 notes to play with. and you can just slip through. And maybe we go full circle and we'll stick a voltage, a LFO, into here to make it fire. Ace. So that is just a few of the very many ways that you can get kind of unconventional sound out of a modular. There are so many other possibilities, so I hope this has given you just a taste and you'll do lots of exploring by yourself as well. Thank you very much for watching, and we'll see you next time. Bye.